All right. Don't forget the first thing I said. If you have point A and point B, and then you are asked to find the locus of point equidistant or equal distance from point A and B. You join A to B, bisect it, and to bisect line AB, you place your compass at A, strike an arc, place it at B, strike the arc again, do the same thing at A, strike the arc below it, at B again, strike the arc and join. So this yellow line is the locus of point equidistant from points A and B. Okay, now if it is locus of point equidistant from point B, only point B. Are you listening?
Yeah.
Only point B. Now you place your compass at B and draw a line, a circle of radius determined by
How
that.
do you know what the radius is though?
Yeah, the radius would have been stated. They could say locus of point 4 centimeter, 4 centimeter, for instance,
Yeah.
equidistant from point B. So locus simply means positions determined by certain stated conditions. For instance, if I want you to locate any region that is not 5 centimeters from where you are sitting, how will you locate that?
You have to locate 5 positions.
Any region that is not more than 5
Okay.
not more than 5 centimeters from where you are sitting.
I'll get a compass and I'll get it 5 centimeters and I'll try to go around myself.
You draw a circle of 5 centimeter radius around yourself.
Yes.
Assuming this is you, B, you get a compass. If the question is, the area must not be more than 5 centimeters from where you are, so you get a compass, and this is you, B, you draw a circle of 5 centimeters around you.
Yeah.
So that every point must be 5 centimeters from you. You know, I think this our circle can be better than this. So let me just use this circle we have here to draw it. This is to be. All right, so something like this. So if you have a point B here, I hope you're seeing what I'm drawing.
Yes, sir.
So if this is 5 centimeters from you, it means everywhere from the center will be 5 centimeters. So this is locus of point 5 centimeters equidistant from a point.
Yeah.
In other words, to draw the locus of point equidistant from a given point, just draw a circle of that radius stated around that point. Is that clear?
Yeah.
To draw the locus of point equidistant from two given points, A and B, what do you do first? I've said that before. What do you do?
You get your compass in more than half.
No.
First
First of all, it says locus of point equidistant from two given points, A and B. What's the first thing you need to do? Join draw a straight line joining A to B.
You make this section parts.
And then after you've joined the straight A to B, forming
You
line
do the
AB.
compassing to make the other line.
So you get a compass, open it to a radius, usually more than half of AB, make an arc up. After placing it at A, you make an arc up. You place it at B again and make an arc to cut. You do the same thing below it. You make an arc at A. You also place it at B and make an arc. And then you join the two positions. These are locus of point equidistant from two given points, A and B. What it simply means is that from anywhere, I don't want to mutilate this diagram too much. I would have showed you that anywhere you are at A, if you move to B, if you move to that line, it will be the same thing. If you also start from B and move there, it will be the same distance. But I have to remove this so I don't mutilate this thing too much. Okay, so better.
So they'll all be
equal distance, you know.
Yeah.
In fact, let me explain it again. If somebody is here, this is what it simply means. If somebody is sitting here, this position, let me mark it. Can you see where I just dotted?
Yeah.
This person that is here is the same distance from A as from B.
Okay.
If we locate another person somewhere here, it's the same distance from A as he is from B.
Yeah.
So that will be locus of point equidistant from point A and B. You know. All right. I've talked about that. Now, finally, locus of point equidistant from two given lines. Let me now write it in yellow. Locus of point equidistant from two lines. The two lines could be AB and BC. AB and BC. Can you see that?
Yeah.
Are you all with me?
Yeah.
Okay, so for instance, this is AB, A to B, and this is BC, B to C. So we want to find locus of point equidistant from two lines, AB and BC. All you need to do is bisect the angle formed between them.
Yeah.
Did you get that?
Yeah.
Bisect the
Do
angle.
you do the angle between B and A and then B and C?
Just the angle formed between the two of them. You know, this is yes, that's the angle formed between line line AB and line BC. That's line AB and line BC. So to do that, of course, you place your compass at where the angle is formed. You place your compass at B, open it to any radius, any radius at all, make an arc like this. Did you see what I did?
Yeah.
And then at these two positions, place your compass at this first point, open it and make an arc. Take it to the next point, open it and make the second arc. So let me do that arc again. It's a sketch, but then it needs to be a reasonable sketch. Now, wherever these two arcs intersect, draw a line from there to cut to meet here. Sorry, I need to do it better. You see this green line? That's it. Mm-hmm. Is this green line that's the locus of point equidistant? How do I explain? Okay, see this green line. That's the locus of point equidistant from line AB and line BC. Because anywhere you are on this green line, for instance, if I'm on this position, I'm dotting as black. The distance from here to here will be the same as the distance from here to here.
Couldn't you have just done that without the compass thing?
No, it can only be gotten correctly with a compass. And again, the only way you could do that without the compass is measure out the angle, and divide it into two equal parts. But then they want to see the construction lines. They will always leave you with an instruction: show all your construction lines.
Yeah.
Let me explain this again. This is about locus of points equidistant from two lines, line AB and line BC. Okay?
Yeah.
And I said, to get that, you have the line AB, you have the line BC, an angle is formed between them. Just bisect the angle. So I can actually say bisect the angle formed between A and B. That's basically what I would write here. Bisect angle ABC. And to bisect angle ABC, you place your compass at B where the angle is formed. Draw a small arc. Now where the arc cuts the two lines, these two positions, which I could call position M and position P, place your compass at those two positions. Position M, open it, make an arc, a reasonable arc of. Then place it again at P, make an arc, another arc where the two arcs intersect. Join that point to B. This line is the locus of point equidistant from line AB and line BC. Is that clear?
Yeah.
Remember, this other one is you bisect the line. Bisect line AB. If it's about locus of point equidistant from points, from two given points, A and B, just bisect line AB. If it is about locus of point equidistant from two given lines, line AB and line BC, bisect angle ABC. Does it make sense?
Yes.
Now, if it is about locus of point equidistant from a given point, use the distance given and draw a circle around that point. So this will be circle of the radius around this point. Okay, any questions so that we can quickly answer this one? It looks like let me take this question to the next page because I've drawn so much on it. I've mutilated it, as I would say. So go to page 12 of 12. Are you there?
Yeah.
It says use the ruler and compasses to construct the perpendicular to the line segment AB that passes through point P. That perpendicular must pass through point P. And perpendicular means what?
Like 90 degree.
It must form angle 90 degree. So the line, what we're going to construct, we run through like this, making angle 90 degree with line AB. But it has to be constructed, and you must show your construction lines. Okay, so how do we do that? I have to first of all explain what it means. First of all, it means draw a line that pass through point B, that will pass through point P, such that that line, this line shown in yellow, must make angle 90 degree with the originally given line AB.
Okay.
Is that understood?
Yes, sir.
Okay, so how do we do that? Let's go to the work. This is what you do. Start from that point P given. Right?
Yeah.
Draw a semicircle like this. Mark the point where the semicircle cuts. This kind of thing is do as I say. As I'm explaining, you have your compass and your relevant drawing instruments, and you're practicing. So if these two positions are, I can call it T and R. Then you get your compass again, place at T, open to a reasonable radius, draw an arc here. Also put it at R, draw an arc here. Remember the radius you used when you place it at T to draw the first arc must be the same radius you use when you place it at R to draw that arc, just like we did in the previous ones we explained here. The same method. The same radius you use here when you place that here is the same radius you use here. Alright, so Can I go through the illustration, the explanation again?
Yeah.
All right.
Kind of get it.
Yeah, that's
No,
cool.
can you just explain it? Okay.
I will say that again. So the perpendicular line, I'm not even done, but the perpendicular line must pass through point P. So I said
Yeah.
the perpendicular line must pass through point P, like this. And I said place your compass at P, draw a small semicircle
Yeah.
that will cut through the given line segment. So assuming the points where it cuts through it are point T and point R, mark those 2 points. Now get your compass again, place at T, open it to a reasonable radius, make an arc.
Okay.
Then place it again at R, open it to a reasonable radius, make an arc.
Look.
Now wherever the arc intersects, you can now join it to this.
Line.
That would be perpendicular. So this is the answer.
Okay.
What's the other one? I think there's a question below it. Read this out. Number 6. I'm on page 12 of 12.
Use ruler compass to construct the bisector of angle PQR.
Use the ruler and compass to construct the bisector of angle PQR. Angle PQR. You must show your construction. Bisector of angle PQR. I've explained it already. How do you find the line that bisects angle PQR?
Okay. Draw an arc.
You place at Q. Are you all listening?
Yeah.
You draw an arc.
Yeah.
Let me use a line. First of all, place at Q. Draw a small arc. Let me draw it again. And then mark these 2 points where the arc cuts the line. I can call them points T and P, or R, or X, or P and Y. So what's the next thing?
You get the compass
Yes.
and you go from either T or Y, it doesn't matter, and then you draw the thing.
An arc. Good. You place at
Yeah,
T.
no.
You place at T. Open it to a reasonable radius. Draw a, and then also with the same radius, place at Y, and cut.
Yeah.
You know,
And then you draw the line.
you just draw the line, turning them. So you draw this to this. In fact, this yellow line is the locus of point equidistant from what? Based on what I explained to you. This is the locus of points equidistant from lines. There are 2 lines that it is equidistant to. Line, because they may ask you, give you a particular line and ask you what that locus represents. Equidistant from lines QR and QP. Is that clear?
Yeah.
All right. What's the next one? This one is on bearing, and I have to carry it to another place too. Okay, still on this same page, I put the bearing question there. Let's zoom it in. Page 12 of 13. I think I need to move this up a bit. So what did it say? Let's zoom it in. So the diagram shows the positions of 2 boats, P and Q. Are you looking at what I'm reading out?
Yeah.
So the diagram shows the position of two boats, P and Q. So this is P, this is Q. And what are we asked to do now? The bearing of a point R from both P is 060 degrees. 060 degrees from P. From P. So from P you measure 060, that's 60 degrees. Did you get that?
Yeah, you did.
Yeah. From P, measure 60 degrees and draw a line such that this will be 60 degrees.
Does the line not touch the other one?
No, just draw it. Eventually, some things will cross out. Just
we
draw.
have 10 minutes now.
Okay. How many minutes?
10.
All right. So 60 degrees. I think we will be able to cover up. Thank you for reminding us. So 60 degrees, that's then another bearing is given. Read this one I'm underlining.
Bearing of was R
310. 310. How would we measure 310? In bearing measurement, we only go clockwise. I hope and clockwise. We don't go anti-clockwise. So you measure clockwise. In other words, let me illustrate first. The angle must be 310 measured clockwise. It's always a clockwise measurement. When you're doing bearing, it must be 310 measured clockwise. Did you get that? So if it is 310 measured clockwise, what should be its value measured anti-clockwise? 50. 50 degrees, right?
Yeah.
So it means you just, from Q, you draw a line 50 degrees. 50 degrees. So, and then that means you need to make this other one longer. Wherever the cut is the position of the R. Is the position of that R we're looking for. Is that understood? I should illustrate again. First of all, it says the bearing of R from both P is 60 degrees. So you measure out 60 degrees from P and draw a line. Don't bother about where the line will get to. Just if you need to make it longer, you can make it longer later. Just draw the yellow line. We have drawn the bearing of R from P, 60 degrees. Then it says the bearing of R from Q is 310. And I told you bearing measurement must be clockwise. So to get 310 degrees clockwise is the same thing as 50 degrees anti-clockwise. I think what you just did was 360 minus 310, isn't it?
Yeah.
Okay, 360 minus 310 will give you 50 degrees anti-clockwise. So you just measure 50 degrees anti-clockwise and then draw a line wherever the cut is, that position R.
So is that just how it's meant to look like?
Pardon?
Is that just how it's meant to look like then?
That's all. You have your three marks. Now it says in the space above, draw an accurate diagram to show the position of point R. Mark the position R with a cross X. That's all. You're done.
Okay.
So you just mark it with X. That's the position. So that's what. All right, next question. Yeah, that's cool. Let's go there. Let me zoom it in so that I can work on it properly. Zoom in. It says the diagram shows the positions of two villages B and W. So B and W. Okay?
Yeah.
Are we all listening? Now it says
Yes, sir.
a scale factor is used. Scale is 4 centimeter represents 1 kilometer. So you will need to, it's drawn to scale, so you carry out some
Oh,
measurement.
you have to use a ruler for that.
Pardon? Yeah, you're
Not
going to use a ruler for that. Say work out the real distance in kilometer of B from W, Beckhampton and West Kenneth. Where is this place? Not of UK or London or where?
I don't know.
Is it a familiar city?
No.
Okay. All right. So
West Kenneth, all the time.
whatever. So B to W, you measure with your ruler, assuming you got BW to be.
Oh, it is in the UK.
I think it should be in the UK.
She went to search it up. Yeah, it's near like Oxford.
Ah, really? Okay.
So it's probably a posh area.
Posh area. Okay, don't worry. Oh, it's near Oxford, so it should be a posh area.
Yeah.
Cool. So, assuming you measured BW and you got, say, 12 centimeters, what's the real length? Remember, 4 centimeter represents 1 kilometer. So that would be equal to what?
It'd be 3 kilometers, yeah. 3 kilometers. Yeah.
No, I said you measured BC. And you got 12, you measured BC to be 12 centimeters. So what is the actual distance, the real length distance of Beckhampton?
Yeah, 3 kilometers. 3 kilometers.
It can be 3 now. Oh, okay. Sorry, 4. I'm sorry. I was the one confusing you. 4 represents 1. All right, that's cool. Yeah, that's cool. Just simple ratio. That's cool. So if 4 centimeter is equal to 1 kilometer, that means 12 centimeters should be
3 kilometers.
X, and X will be 3 kilometers. That's all. So what's the next thing? You just get this by cross multiplying this time, this time, this together. All right. It says the village Avebury, however it is pronounced, is on a bearing of 38 from Beckhampton.
A is 6 centimeters from B.
Okay, so A is on a bearing of 38 from Beckhampton. A is 38 from Beckhampton, bearing of 38. So from B, that's Beckhampton, you measure 38 degrees. Assuming this is the measurement, you just measure 38 degrees and draw your line.
Wow. Oh, okay. Oh, we have 2 minutes left.
Okay, so 38 degrees, and what else do you need? Thank you for the reminder.
I need to draw a line of 6 centimeters.
And it says it should be 6 centimeters. So on the diagram, A is 6 centimeters from B. So you measure 6 centimeters. Assuming the 6 centimeters stops at here, you stop at here 6 centimeters. What else are we asked to do? Mark with a cross. So this is where A will be, with a cross. This is A. What else are we asked to do? Is that all?
Yeah.
That's all for this question. On the diagram, mark A with a cross. Label the cross A.
4 marks.
That's all. Assuming they asked us the one from B2, you would have drawn the bearing from B and then join, and then you look for where they are cutting. That's basically it. And you have your 4 marks.
Can you script?
Yes, let's look at this question on the right. Yes, this one.
The first part, you're gonna have to use a compass for that.
Let's even see what it is, if it is something that we're.
I don't think it is.
Look at it.
I think one.
If it is similar, we don't need to bother about ourselves.
Or can we go on the one, on the next page? The next page. The marker. Can we go on that one?
Okay.
I agree.
All right. I think this one shouldn't be problems. It's just similar method can be done. All right. So next one on the next page.
Yes.
That's can you circle it? Is it this one?
Yeah, that one.
This one, right?
Yes.
Let me zoom it in. All right. It says a ship sails from P to Q and then Q to R. Q is 12 miles from P on a bearing of 068 or 080. It's already given. R is 28 miles from Q on a bearing of 155 and it's already given. You see, P to Q on a bearing of 80, then 12 miles. How can you even do this? Can you sketch it, assuming it wasn't sketched?
Yeah.
Sometimes this might not be sketched. You can sketch it by yourself. This is what I want to do. Let me cover it briefly and then get you guys to sketch it first of all, so that you just practice. I'm covering it briefly. Then we sketch it on the right hand side. Shall we?
But we've seen it already.
But just to illustrate how that can be done, in case you're not given the sketch itself. It says a ship says from P to Q. Q is 12 miles from P on a bearing of 80. So you start from, it says from P. So you mark a point and call it P.
Wait, no, don't you first draw the north line?
Exactly. First of all, you need to mark a point now. You know, to know where to draw the north line. It has to be at a point. You draw your north line at that point, P. And
what's the line here? What's the line here?
Okay, so the bearing is 080. So you do 080, you measure out 080. Yeah, measure out 080. So this angle should be 80 degrees clockwise. And it says it is what distance from P? 12 miles.
Yeah.
So you measure out, you just write 12 miles. So that, assuming this is now where Q is, we can.
And then you draw another north line
Exactly.
at the end of the
Exactly. Draw another north line.
And you measure 155 degrees.
You measure 155 degrees. 155 degrees might just be somewhere around here. So that here is 155. 155 degrees clockwise. So that's it. This is now position what?
Q.
Position R.
That's R to Q, yeah. Then R to Q is in R.
Remember, this place it was actually Q. P to Q and then Q to R. Now here is now R.
Oh, yeah.
This is R. You know.
Yeah.
And then the
That's
question.
28 so.
The question says, what?
Work out the direct distance from P to R.
P to R. Work out the direct distance from P to R. So we're just going
So
to
like you draw a line from P to R.
P to R. Good. And and just find it. By the way, the distance of Q to R is given as 12.
Wait, this is like the area of a triangle, isn't it?
But no, it's distance they're asking for, not area. Sometimes they may ask you for area, but this one is about distance.
Oh, yeah.
So this.
Oh, this is cosine.
Beautiful, it's cosine rule. So this is 28. You use cosine rule.
We first need to.
But you need to find this angle at Q.
Yeah.
That's you need to find angle PQR. So let me now review the diagram so that we will complete it there.
Do you do 360 take away 155?
No, that we have, but that's not correct. Are we all here, every one of you?
Yeah.
360 take away 155 will give you this whole place. But that's not all that we need, but it's part of what you will do. Remember, what we need is just this angle, the one I drew in blue.
Oh, do you take away 80 as well?
Here is not 80. The one I'm going to draw in green is not necessarily 80. This one I draw in green is not necessarily 80. So you need to find out what that one is. Are you listening?
Is it 100? I think
it is 100.
Yeah,
How do you know it's 100? How do you know it's 100?
Because it's a straight line.
Yeah, not necessarily because it's straight line. When you have
parallel line and then
a transversal. When you have a parallel line, and a transversal, the angles internal angles and interior angles rather, on the same side of the transversal will sum up to 180. I think I need to illustrate that in detail.
So it'd be 155 take away 100.
Yes, cool.
Which is
just a simple illustration. If you have these, you have these. If this is A, this is B, and then you have these E, and then you have these F. A plus B is 180, right?
Yeah.
Okay. And E plus F is 182, so A plus B is equal to 180 because both of them are on the same side of this transversal. The transversal is this black line. The green lines are the parallel lines, so A and B are on the same side. So E plus F is also 180.
So the angle is 55 degrees.
Okay.
And then
okay, first of all, what's the value of this green angle here?
100.
100, okay. The green one is 100. What's the value of the red angle?
100 plus.
No, the whole red angle.
360 take away 155.
Yeah, 360 take away 155. What do you get? 205, right? So that whole place is 205. So what's the value of the angle in blue now?
205 take away 100.
205 take away 100, and that gives us what?
105.
105, yeah.
105. So it's 105 we are using because we are asked to find the length of P to R.
So then you do, is it like A squared equals B squared plus C squared minus 2BC?
Exactly.
I can't remember, but they give us that formula anyway.
Oh, it's given, right?
Yeah, it's given.
That's cosine rule. It's given in the formula table. Is it given to you in the formula table? So just apply cosine. It says work out the direct distance from P to R. Distance P to R. So you use cosine rule.
Yeah.
So it's going to be PR squared is equal to 12 squared plus. Anyway, since it's given in the formula table, let me just write it out in black. PR squared is equal to what again? 12 squared plus 28 squared minus 2 times 12 times 28, then times cos 105. Yeah.
Wait, is Isn't that divided by something? Is it just that?
What did you say?
Is it all divided by something, or is it just that?
Yes, that's all. You're not dividing by anything. Once you find PR squared, you take square root. It's just that. You're not dividing by anything. But you need to be careful. You need to be careful of the lines you're using. Just the two lines that form the included angle. This blue angle is called the included angle of line PQ and line QR. That's the angle formed between them is called the included angle. So the sides you will use are 12 and 28 that form the angle at Q. 12 and 28. So 12 squared plus 28 squared minus 2 times 12 times 28 equals 105. Let's go.
I got 33 points.
Is it everything or just PR squared?
Wait, from what do you get?
Well, I don't know. My calculator isn't working.
It has to work.
It's okay. I have another one, but it's in my school bag, and it's
Okay,
far away.
let's go. What did you say you got?
I got 33.195.
33 points.
195.
So 33.2 miles will be fine. So if it is not stated, you can leave your answer to 3 significant figures.
Okay.
That's just it.
Oh, that was a nice question.
Yeah, it's as easy as
But
that.
you know the thing, you know when you find the angle PQR, that's a bit confusing though.
Yes, once you find angle PQR, every other thing is easy.
You know, if it was if the bearing was 50 degrees instead of 80, does that mean the green angle would be 130?
If the bearing from where to where?
Bearing from Q to P, I think.
Was
Wait, let me show you.
yeah, just use your lesson and show me.
This one here. Did you see?
Yeah, I can see. Okay, I mean if
Like
it was what?
If that was 50 degrees, then does that mean this angle here would be
130.
130?
30, yes. Only this angle in green. If this one was 50 degrees, 50, then this would have been 130. Remember the rule. The rule is A plus B, this plus this. So long as these two lines are parallel, these green lines, and we normally indicate green line with parallel lines with arrow. If they are parallel, it means, and this black line is a transversal that crosses the two. So angles, interior angles on the same side of a transversal sum up to 180. So A plus B equal to 180. Also E plus F equal to 180. And of course, you know what we call alternate angles. Which ones are alternate?
A and F.
So A is equal to F, the alternate angles.
Yeah.
B is equal to E, alternate angles. And then you know corresponding angles. So since we touched on it, let me just add it. Let me call this G, H, H, I, I, then J. So which ones are, you said you gave me alternate as what again?
Alternate angles are equal.
What are the alternate angles? A is equal to F,
and E is equal to B.
and E is equal to B are alternate angles, and they are equal. So which ones are corresponding? Because this is usually very important in solving bearing. You need to know which ones are corresponding.
What the H?
G, if I pick G, you will pick B.
Yeah.
If I pick H, you pick F, isn't it? If I pick
Okay.
A, you pick I. If I pick
Yeah.
E, you pick J.
Yeah.
So give me the corresponding angles again.
So if you pick G, you'd pick B. If you picked H, you'd pick F. If
So
you picked
G is
E,
equal to
you'd
B.
pick J. And
is-
A is I.
H is equal to F, and so on.
Yeah.
And E is equal to J, and so on. So they are all corresponding. These ones are corresponding angles. And they are also equal. You know about vertical opposite angles? The ones that form
Yeah.
an X. G is equal to E.
Yeah.
Okay, they are vertical opposite angles. They are also equal. G is equal to E. H is equal to what?
A.
H is equal to A. Of course, F equal to I. And so on. This F is equal to I here. Alright, that's basically what you need in understanding varying vertically opposite angles. And they are also equal. Is that fine?
Yeah.
Okay. So sometimes you might be asked to find, for instance, in this particular question, where we have, let me zoom it in a bit. So the diagram shows the position of two airports, A and B. The plane flies from airport A to airport B, A to B, and it says, measure the size of angle marked X, this angle. Assuming we measured it and we got 120 degrees. Now, if here is 120 degrees, we can make this line longer. And obviously, this will be 60 degrees because some of the angles on a straight line is 180 degrees. So this is 120, this is 60 degrees. Okay, now assuming the distance from airport A to airport B is 40 kilometers. That's line AB is 40 kilometers. And you are asked to find how far B is southwards or south of A. How far is B south of A? How far is this B south of this A? Just going to the south. How far is B southwards of A? All you need to do is find, first of all, remember line AB is 40, and the angle here, this angle is 60 degrees. So how far B is southwards of A is simply asking you to find line A to E, this line. How far you move down due south, and then you will get to the plane of B. So how far is B southwards of A is the length of AE. So we have to find line AE. And so if you check out this triangle, this is the hypotenuse, AB is the hypotenuse, AE is the adjacent. So adjacent and hypotenuse is cosine. So adjacent over hypotenuse, AE over 40 is cos 60. So you can get AE as 40 times cos 60, which is 20 kilometers. So it means B is 20 kilometers southwards of A. The distance from A to E going towards the south is 20 kilometers. Now if you are asked to find how far is B eastwards of A, eastwards of A, this is A, how far is B towards the east of it is this line. So you have to find line EB, E to B. This is a right angle triangle. So EB over 40 is sine theta, because EB is the opposite of the 60 degrees. And of course, AB is the hypotenuse. So EB over 40 is sine 60. EB gives us 40 sine 60. And the answer is 20 root 2, 3 kilometers. So, some other time, the moment can be given, the bearing can be given like this. Let me see another question. We can verify that. Okay, let's look at this question. It says point C and D are shown in on a different grid, centimeter grid. This is point C, this is point D. And the question says, work out the bearing of D from C. The bearing of D from C. The bearing of D from C. So you start the measurement from C. Remember, you always face your knot. So you measure the angle until you get to D. Angle that we will measure until we get to D is the bearing of D from C. And you can see it's 180 degrees. That's a straight line. So the bearing of D from C is 180 degrees. Bearing of D from C. You can even join these lines. It's 180 degrees, which of course is this angle. Now, assuming there's another point B, such that the bearing of B from C is 60 degrees. This one I showed in green. If the bearing of B from C is 60 degrees, that's the bearing of B from C, measured from C, if it is 60 degrees. Now, find the bearing of C from B. Now, this time around, it is from B. How much you will cover in terms of the angle before you see C? Always starting from the north. You move from the north, cover a clockwise direction to be able to see C. So that's the bearing of C from B. From B is where you draw it. Now, how do we get this value, this angle? First of all, from our previous discussion, we have shown that if this is 60, here has to be 120, because they are the same angles on the same side of the transversal. We add up to 180. If this is 60, this must be 120, so that it will add up to 180. And if this is 120, how do we get the value of this one in blue? If the one in red is 120, how do we get the value of the one in blue? Everything is 360. So it will be 360 minus 120. This whole 360, remove 120. And that gives us 240. 240. So the bearing of C from B is 240. You can see it. Sometimes they may ask you due east or due south or due west. If you are at this point and you are to measure due east, just means go towards the east, the bearing will be 90 degrees, because you always measure bearing from the north. So 90 degrees is due east. If it is due south, it means from facing the north, you will move, you rotate towards the south. That's 180 degrees. The bearing due west, you start from north again, you move until you get to the west. North, you move until you get to the west. This whole angle is 270 degrees. So due west is 270 degrees. So these are things you can take note of. Some other time it might be requiring you to find the shortest distance. Like you may be asked to find the shortest distance between a particular point. Let me look for a question like that where we have something to do with shortest distance. Let me see. Okay. Like if this is line AB, and there's a point C here, so that the angle between this angle here, or the distance between C and B, is 100 kilometers. The shortest distance between point C, this point C, and line AB is this line in yellow, which is perpendicular to AB at 90 degrees to AB. So the shortest distance between point C and line AB, between point C and line AB, is this yellow line CM, which is 90 degrees, that makes angle 90 degrees with line AB. So that's the shortest distance between point C and line AB. The yellow line that makes angle 90 degrees with line AB. A perpendicular line to line AB is the shortest. That's the shortest distance. Every other distance from C will be longer. If you move this way, it is longer. I mean, every other distance from C to line AB will be longer. If you move from here to here, it's longer. If you move from here to here, it's longer. Move from here to here, it's longer. Move from here to here, it's longer. The shortest is just directly to line AB, making angle 90 degrees from with it. So CM is the shortest distance. And of course, we can get CM using, what rule can we use? This is hypotenuse, this is adjacent. So we can say cos CM over, no, not cos, CM over 100 is equal to cos 100. Let me write it better. So this is adjacent, considering this angle, this is adjacent, and this is hypotenuse, because this is opposite. So CM over 100 is equal to cos 20 degrees. So we can find CM. CM is equal to 100 times cos 20 degrees. That's the shortest distance between point C and line AB, between point C and line AB, the perpendicular line that runs from point C to line AB. Okay.